Did it work? I think it switched. Cool. Alright, so I'm gonna try a series of streams / probably videos that I will put on YouTube and other who knows what. But the goal of this is to do like a full stack development. So basically designing a keyboard from the ground up, from everything. So kind of just my methodology on doing it and how I do it, and yeah, just the way I do it. It might not be perfectly applicable to everyone since a lot of people don't use the same software I use. However, it might just be cool to see. I don't know. It's just an idea that I had that I've been wanting to do, so I figured I want to design a new keyboard, so I should maybe do this. Just to do it. I think it should be fun to do. So yeah, we'll try it out. Yeah, we're gonna give it a shot. Alright, cool. This is gonna be my Ibis keyboard. I was just kind of messing around here with some of the PCB shit. However, the first thing we're actually gonna do is not that. It's going to be, excuse me, the actual layout. If keyboard layout editor opens, which it did, cool. Browser source, add source, Chrome. What's up, guys? Add source, URL. That's not what I want to do. Delete. Thank you for following Ham Time. Much obliged. How the hell do I do this? Media source, window capture. Cancel. Alright, fuck it. We're just gonna do it this way. Alright. So we're gonna make the layout for this. I usually start with like your 104, but we're obviously not gonna use that. We're gonna do some other fun shit here. Here, let me do this. Let's do it this way. Keyboardlayouteditor.com. So it's just going to kind of be what I guess the layouts we're going to use. So the goal here is use the Duck Blackbird layout. Except basically fuck HHKB. I'm not gonna do HHKB. I think it's ugly. So we're gonna do just standard. So this is kind of what we're gonna do right here. In essence. Yes, like I said, I like to start with the base like 104 key layout. Yeah, exactly. Yeah, it's just not good. Edit that. I think the big thing here is what? Is 1.5 or 1.25? I guess we'll find out. Because I want to use a 7U bottom row. Because I like the 7U. So we're gonna do what I like because it's my fucking keyboard. Nope, don't select the one. And it's not going to be, you know, like an exact copy / clone / whatever other word you want to use. You know, I'm going to make it my own a little bit here. Alright, that was easy. Cool. But yeah, now you have like an ugly gap here because the goal here is to keep this 0.25U. So the U is like one key. One square key is one U. So this is a 0.25U, 1/4 of that gap. So if I move this over 1, the gap's filled. The goal is to kind of maintain that gap in this whole bezel area. So right here, like that needs to be like that. for example. So let's just copy this a couple times and come up with some bottom rows. So like I said, I want to use a 7U bottom row myself just because I like that. Let me move that over one. So this would be like, I want to do a 1 keyless blocker though. I don't want to do a non-1 keyless blocker. And see, this is going to be kind of shitty here. Actually, no, it's not. Because I can do two 1.5 here. So that's actually pretty good. Delete the stock one. So that'll be like one layout option right there. Those are 1.5s, yeah. So another thing we could do is copy this. And you can ignore like the key codes. Like these aren't going to be win in menu. I'll just make them blank because it doesn't matter. But here I want to do like 3 1U keys. I think would be kind of nice. Add a key. Yeah, I think a 1U blocker on the left would be a nice evening out. Because you kind of have a little bit of like the bezel here and then no bezel, or then like one bezel here. For example, that could be it. And then you can't really put a blocker here unless you put like a 1U blocker between the two 1U keys, which I think would be kind of dumb. But that's just me. I don't like that idea. So we're not going to do that. However, I do want to do a 625. What the hell? Oh, there we go. Oh, we are here. We're going to use that for later. For my man's condo. Through you is, I agree, never the play. However, we're going to try it. So what is that? That's 1.51, 1.5, then 1.25s. It's easy enough. All right, Mart, be nice. So that's gonna be another option. Honestly, I might just kind of stick with those 3. Anyone that wants a 1.25 bottom row could suck me off. Yeah. I might get rid of these. Fuck it, I don't like those. Hi, Haley. Yeah, so that'll be the idea. Oh, we gotta do fucking split backspace. We gotta do fucking this stuff. Stepped caps lock. Because if you're not using stepped caps lock in 2020, you're kidding yourself. Yeah, people like split backspace. I don't know, dude. I don't know. I don't care enough to argue. This is the fucking split right shift. You know, we should also do, just to appease like the 8 people. Actually, less than that would care. Oh, Zombumon, you look even more beautiful today. If you cheer more, I'll say your name more times. I'm trying to get some simps going. Should we do ISO? Maybe. I'm thinking about it. It's fucking easy. Fuck it. I'll do a fixed plate and then an ISO plate. Yeah, there's your ISO. Easy game. Alright, so that's all we're going to do for this. Straightforward, easy. Not too bad. PCB steps are fine typically if you do ISO. I don't really see the issue with it. Yeah, I'll do 2 different plates for sure. It's going to be like a fixed good plate and then like a plate for stupid layouts. But anyway, we're not doing that today. We're going to do the PCB, but I needed to get the layout figured out for the most part. just to verify that, like, I like what I'm doing. Does that make sense? So I can get the switch matrix done. So this is the base. We're gonna do an STM based PCB this time, which I usually don't do, but I will do this time. So actually Gondo sent me this really useful little graphic here to know which capacitors go in which, because I always forget, so I was gonna edit this real quick. So VBAT gets 100 nano. So VBAT gets his 100 nano. VDD and VSS, or so this one's gonna be pin 48. I'll do that. I'm gonna do that. Text 1. So I know what pins these go on. 48s. Which one did I get? I got 100 nano as well. Fuck off. Fuck knobs, dude. I don't like knobs. People are like, dude, knobs are so cool on keyboards. Like, I'm never gonna use it. I'm not gonna put on a keyboard of my own. Basically. So I'm sorry. As I've said before, if you want to be a knob, you can be a knob. However, I do not want to be a knob. So I'm not gonna be a knob. 100 nano. 36 and a 4.7. Nope, it needs to be 36. Yeah, I think knobs are ugly. They have their purpose, probably, but I don't want to do it. That's 24, right? 100 nano, 24. And then the other two go on pin 9. 1 unit 10 nano. So I'm gonna actually make this like nicer again. Maybe. Actually, no. We're gonna leave that out. Just I like that. That'll work for me. All right. So the base is done, and the way I do these, as you guys will see here, so I'll do it right now. So this is like the actual main schematic that I'm gonna be using, which will have everything that I need on it. The cool part is I don't need to put all of this stuff like copied and pasted. I'm gonna annotate this real quick. Update change list. Accept. Anyway, so we don't have to take all this stuff and copy it over. What I do is, since I have it referenced in my project itself, I can just add it as a sheet symbol. So like here you can see this one's USB-C. However, we'll put that one in later. So this here is the microcontroller. So that's a symbol for all this. Sheet symbol actions, let's make this taller. And so what I can do here is synchronize all this shit. And there's all my IO. Makes it super fucking clean and nice. Why do I have 2 grounds and 2 ground buses? That's kind of weird. Oh, because I have 2 ports. Alright, I gotta fix that. Oh yeah, I don't need this. Or this. I copied this shit. This is all ESD stuff. I copied all this from another schematic, so I had to fix that. Alright, we should be good now. Yeah, the headphone amp thing, that was kind of dumb. I'll just delete those, I guess. Alright, cool. So I guess the next thing with this is we can start doing all my fucking fun shit. Ground bus. I have 2 grounds here. for USB stuff. We'll go over that in a bit. What's up, Soren? How you doing, bro? Alright, so this is my microcontroller and all this shit. So that's easy to do. We'll do the same thing here for the USB-C. So it's like this. I hate, sometimes it like doesn't switch over. I don't know why. Alright, fuck it. There we go, choosable USB-C. And this one's gonna be the LED MOSFET that I use. So I'll put this up here because this is how to control the LEDs on and off. And then the last one will be the switch matrix, which right now might not be done. No, that's not done. I haven't done that one yet. All right, so this is basically everything. So like, these are my USB symbols or signals. So here's my USB port. Here are my CC lines. All this is already like fully ready to go, which is sweet. It's super easy. So all I have to do here is organize these nicely so they're not in the wrong order. Net them out. USB negative, USB positive. And then I copy this. So here. So now this is connected to this. Very easy, very easy. Now I'll do the same thing for all these fucking stupid power ports, VCC. So VCC and VBus. VBus is coming directly in from the USB port. VCC is like a cleaned out, smooth version of that after all the ESD stuff's done. Badboy94, thank you for wasting your money on me and subscribing. Appreciate it. So this would be ground bus. So that'd be a power ground, I guess we'll do. That's such a big fucking... There we go. USB shield, let's make that shield. So I need that here. Ground bus, and we'll make this one ground. So those will be tied together now real nicely and easily. This music's kind of lame as shit, but it's free. So hopefully I don't get any kind of copyright stuff if I put this on YouTube. Thank you, Shitshot, for the follow. Is your name Shitshot because you like suck at FPSs and stuff? I would assume so. Alright, cool. So this is all I want to do with this for now. We'll concentrate on the switch matrix the rest of the time. So this is, I think, the switch matrix from my H88. So this isn't what we're gonna use. Holy fuck. Okay, anyway. So we're not gonna do this exact matrix, but it's a good like starting point, I guess. So I don't have to do everything over. However, I am gonna like delete half of this stuff, so it's fun. Actually, yeah, fuck it. I'm gonna start over. Alright. Alright, so I gotta add some switches. So I have a whole bunch of different ones. I have like hot swaps, I have some keep out, I have non-keep out, I have hybrids. I might continue with the hybrid stuff. Cause I kinda like, dude, I miss Unreal Tournament. Unreal Tournament was fun. We played that all the time in like high school. I think we played UT 2004 in like 2011. Those are the days. It was like so heavily modded because each like generation of student would add more and more shit into the folder that we would copy onto our C drives. I haven't played. Actually no, I did play the newer one. I don't know if it's the newest one, but I played it a bit, like probably 2 or 3 years ago. I want to say. It just has so much nostalgia associated with it in my head. I'm getting excited. Anyway, so yeah, I think I'm gonna do the hybrid MX Alps stuff. And I'm not gonna name these yet. It's like this is MX question mark. Actually, you know what? I think I do kind of want to name these in a different way. So one thing I do want to do here that I should have done. So I'm gonna make this so I can put which key is which, because I think I want to put that as like one of my new fucking quote unquote features. Value escape. Why does that show up twice? Oh. General. Yep, that'll show up there. So compile. Hot swap H80 when? Probably whenever I get around to just doing it, because I do want to do that. Yes, Duck Boy, I am a nerd. Alright. So this will be escape. Escape, this will be F1. This is easy for me to like keep track of what's what, I guess. F2, blah, blah, blah. Thank you, Sagan, for that follow. F4. This probably take a little longer than normal because today I just click and go, but we're doing this a nice way. F8. I'd be sick if I get these to increment nicely, but that won't happen. See, like I said, sometimes I do try to like reuse these, but since I'm sort of doing a new method, I may as well start it over. Mountain blocks cheered. Thank you. I appreciate that. Yeah, so honestly the main reason I'm doing this is so I kind of know what's what. So if this one I'm going to do stab down. I'm going to do south facing stabs, I think, for most of this. Oh, I think I'm going to make a bigger sheet. Goddamn. Thanks for cheering those bits. Aren't you making an effortless 800? Yes, I am. Yes, that is what this is. So what does that have to do with anything? I'm not following. We're also gonna need a key here for the short back or the split backspace. So do that, and then it was just gonna be page up. We'll just call it page up. Doesn't matter. IBIS 2.4 after H60. H60 protos are like coming in now, so this is probably gonna be down the line sort of thing. It's just gonna be fun to do. I don't know. Make this one num. I don't even know what the hell keys are on the keyboard anymore. Num divide. This would be num. That thing. I'll do pause because I like pause here. Or no, what typically goes there? Minus. Num minus. Yeah, honestly, it's Altium is very similar to KiCad as far as like, you know, maybe not workflow, but like the idea is the same. Like what you do is the same. But yeah, the workflow is different. The, you know, shortcuts, how things are treated are different. The library management is far superior in Altium, I would say, definitely. That's probably the biggest allure, at least for me. So I actually used the wrong footprint here. I wanted to use the combo backspace LED. Yeah, there we go. And I think that's on this side. Cool. And I can actually physically like kind of separate these a little bit. That'll work. Just to kind of give like a physical view of what the hell is going on. So yeah, that's the first row. So this would be what, a 1.5 view? It'll be tab, Monkers. Hi Zach. So be Q, W, E, not U, E. R, T, Y, U, I, O, nope, P, bracket, bracket, and then this is a 1.5 pipe key. I'll just call it that. All right, is that right? Tab, Q, W, E, R, T, Y, U, I, O, P, bracket, bracket, that guy. So yeah, you can definitely see there's like already a bit of, oh, I see what you meant, Zambamon. So yeah, these aren't F keys. These are actually just like my numero. So I should have just labeled them the numero keys instead. I was thinking weird shit in my head. But luckily it's this easy. 7, 8, 9. So that's why I was like thinking to myself, this is kind of wide. That's why it was kind of wide. Yes, this is Altium. Yeah, so there's my top row and then second row. We'll call this one what? Page down? This would be what, 7? Nope. Wrong fucking thing again. Eight, 9, typoed on that. And then this one would be, I forget how I do these. So I want this to be combo num when you to use stab LED. So I forget what the hell that looks like. So I'm gonna make this, I think I'm gonna make this one like the upper split. So I'll call that one split minus. But like I said, I actually kind of forget what the hell that looks like. So let's take a look. Import changes. No. Change my mind. Yes, I made all these footprints and all this stuff I made. I kind of had to because keyboard libraries don't exist for Altium, but I've been using this for like 3 or 4 years at this point. That I can just do them all anyway. I may as well. It's good practice too. I do this stuff like IRL, so it's useful for that. Don't show, it doesn't matter because I'm deleting all of these. Actually, I want to Remove all those nets. Disable all. Remove nets. And I only want to add these MX switches for now. Nope. Disable selected. Disable all. Left same kind. Enable selected. So I'm doing this to see. Ignore all that green shit. 39. I want to see what MX39 looks like. Okay, so MX39 is the bottom part. Okay, cool. So I want to make. So this is wrong. I don't want to make this one the 2U. I want to make the bottom of the 2U. So when we do that, we're gonna go combo num 1U 2U blah blah blah, and this will be my split plus. Cool. And this will be what? 6? H89, F14. Just a straight line of keys, like no breaks between them. I can see some dumbass trying to do that. Not 54, I just need 4. That's okay. This will be 1. 2, 3, and then the same thing as these upper two. I'm gonna make this one like, should I do a split up? Call it one split enter up, and this one will be split enter down. It doesn't really matter. No, I'm changing the wrong thing again on this. Splits, it's down. H105, dude, just wait. I'm gonna do that. The H104, it's gonna be sick. For a keyboard for a friend of mine. MX Alps 1. So this would be what, like the dot key? Call it dot. Fuck, did it again. And this would be my 0. Cool. Alright, so anyway, let's go back to the main alphas over here. MX Alps hybrid. This will be a stepped caps lock and regular caps lock combo. So it'll be a combo caps LED. Do 1Us. Full size customs, dude. It's gonna happen. I'm waiting for it to happen. The demand is, I think, finally there. So I think that'd be neat. S D F G H J K L colon, call that the colon key, and then the quote key, and then this is going to be a 1U ISO key, 1U ISO dumb, and then this will be enter, which will just be one combo enter key. So yeah, that will be that. So this one we're going to do split shift. This is left shift, not right shift. Combo left shift. ISO 1U dumb also. ISO 1U dumb again. Z. X. C. V. B. N. M. comma, period. I'll call it dot again because I think that's like the keyboard key code version. This will be like the other slash, and then this will be a regular R shift. And a 1U split, we'll call this FN, I guess. Oh, I want that to be that. I want it to be that. All right, cool. And now just the bottom row is left to do. And I think we're doing what? 2 different? Yeah. So yeah, 2 different ones. 1 5 1 1 5 7. So that's easy. 1.5U. We'll call this control. Control 1. Or let's do 150 control. 1.5 control. This would be 1U win. This would be 1.5 alt. And then we'll do the same thing here. Yeah, make sure that's a 1U, not a 1.5. Oh, so yeah, so those are the only bottom rows we're doing. Cool, so that's easy there. Then we can do a 7U shift and a 6.5U shift. So typically you can see here, like the center of this is over the N key. So I'll just make them both under the N key. So they will be here. Combo, RC 7U, shift, stab down. I like south-facing stabs. I'll make this one the 6.5, 6.25U. What's up, Tonka? So 675. All right, cool. So I'm gonna copy these since these are my 1.5s. I just put them over here. I do want to leave. Actually, I'm gonna group the 1.5U and the 1.25U control. My first custom like keyboard I owned or one I designed. The first custom one I owned was probably, I think it was my I don't even know. What was my first custom keyboard I owned? I want to say my Jane V2, but I don't think that's correct. Maybe my original HPCP. No, Biscotti was before that. Maybe Biscotti. I honestly don't know. Or maybe the meme. One of those. I don't even have half those boards anymore. I think it was one of those. But then again, I designed the meme. Like the first custom board I didn't design myself that I bought or that I owned was my Jane V2 that I have. I'd say that one. So I want this to be under the right shift, and then this one would be right under here. So we'll do 1.25 U's. So this would be what? 1.25U, nope, MX. 1.25U alt. I'm 25U win, I'm 25U control. And I'm naming these the right thing. 1.5U control. 1.5U alt. All right, cool. So there's my switch matrix. I think for right now, actually no. So kind of the next step I want to do is simplify this a little bit, make it a little better. So right now, like this would work perfectly well the way it is. There's nothing wrong with this layout. However, it's not extremely efficient. For example, you have 5 rows, so row 1, row 2, row 3, row 4, and row 5. So like the 2 space keys here will share a row. Same with my wins and my controls. They're going to share. They're the same key, just 2 footprints on the same key. And you have your columns, 1, 2, 3, blah, blah, blah. So the issue are these couple keys here, where like if I left this how it is, my main backspace key, MX15, would have its own column. And then my page up and my page down, my 2 like little 1U keys in between, will also just have their own column. So that's okay, but sometimes you're forced to use a certain amount of I/O. Luckily with this STM, I don't really have that issue. So I could just leave this how it is, but I don't want to do that. I want to make this better, basically. So I'm just going to move these 2 down into here. So all this does is change like the physical key map, basically. But you can still place these wherever you want. Like, just because this MX36 is where it is, like in the row in the column matrix, I could still place it over here if I want to. It really does make a difference there. So with these, I'll actually do the placement here in a second. I'll just have to run like a row up and over, and then I'll join the columns up as I go. So anyway, let's do that real quick. So I'm going to do the annotation again. So I could have clicked through here and like done the MX 1, 2, 3, blah, 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 the whole way through. But it's sometimes faster and easier just to use the built-in annotation tool. So you can see some of these are already named, like MX, MX1, MX2, blah, blah, blah. But then down here at the bottom, there's a bunch that aren't named. So I'm going to reset them all. And then here, this is pretty cool because you can change like how it will name things in a schematic that aren't named already or that you want named. So yeah, I'm just going to do the changes here. So now these should all be named as they would be horizontally and then diagonally. So yeah, that's pretty neat. Have I ever thought about making an H40 macro pad? Like a 4x4 pad? I could, yeah. I haven't really done too many macro pad type things. I do have a Numpad Pcb here. Let me find it. I need to build it for my man, Mr. Zekin, because he has a prototype waiting for said PCB. So here's that. It's just a simple little USB Type-C PCB. Nothing crazy. Hey, Petro. Yeah, I need to solder one of those up for my mains, Mr. Zekin. And I'm knocking shit off the walls. Cool. All right. So at this point, we're good to go with. Hey, thank you, Bard, for the follow. BA__RD. So at this point, let's see if I can make this smaller. Nope. D. That's like the only 2 sizes. One's too big, one's too little. Story of my life. No, S&D is not too bad. I usually get stuff assembled by JLC PCB. They'll do like an assembly service where you can get a lot of the stuff assembled, but not everything. But whatever they can assemble or they don't have parts in for, I usually just like hot air, solder myself. I do it a lot, so I'm pretty good at this point. But yeah, solder paste and hot air. It's not too bad. So like I was saying, at this point, we could proceed with getting the PCB to a point where we can import it into SolidWorks and start actually doing the case. Enable all the same kind. Nope, disable the same kind. So I'm going to import my switches and I'm going to import my USB port because that's all I care about right now. Do I use JLC for everything? So I use JLC for like these prototypes and stuff that I do, but typically for a production PCB, I like to use Elecro just because I have a good relationship with them at this point because I've done so many PCBs through them. I think all of my larger buys that I've done have been through Elecro. All right, so these things are going to turn bright green all the time because none of my design rules are in check. Let's do that, actually. Design rules are good to do. So design rules and constraints are basically telling your PCB software how to behave in certain situations. So a big one is your clearance rules. So this is telling you, there are a couple different scenarios here where you have track to track to SMD pad, through hole pad via copper, text, holes, etc. And every fab is going to kind of have a different set of rules for the most part. So we can just go to like Electro. Let's do this. Electro PCB rules. So these are pretty straightforward and easy. PCB color doesn't matter, blah blah blah, doesn't matter. Stencils doesn't matter for this. So it's actually cool because they use Altium too when they do this. So yeah, so it's rules to follow stuff. Typically, you can kind of just set them and run as long as you set them to start. So I usually go off their minimum rules, which is easy. So like for silkscreen, let's do this. Silk to silk antenna, and half the trouble is finding out where the fuck to put, where the rules are. Solder mask, nope, that's masks. I want to do silk. Silk to any silk, text any silk, blah blah blah. I think actually the silk, I usually do the silk when I'm actually placing it, so that should make a difference. I could be wrong. Clearance, blah blah, width. Okay, width power. Oh yeah, so I already have like defaults kind of set up. Anyway, so their minimum clearances are 6 mil to everything. So that's a good rule of thumb to start with that. But I also like to change my via to copper one to 12 because that just makes it less likely that if you have a copper port like ground, power, etc., they don't interact with vias they should not be interacting with, because vias are a bigger part of PCBs than typical stuff is. So holes, I'll do like 10. Typically doesn't make a difference. My width's already set up, so I usually use 6 mils for my clearances, or for my like signal traces. So like your columns, your rows, USB, all that kind of stuff. 6 mil is usually fine. But for power, because you're dealing with higher currents typically than your data lines would have, I like to do at least 10 mil, hopefully 12, but I can do up to 20. So like my VCC coming straight from my USB port to my MCU, I will make that typically 20 or like 18, something like that, to make it just larger. The other big one to pay attention to is your vias. So I do these in mils, which is 1 mil is 1,000th of an inch. So I usually do that. And they kind of do theirs in millimeters. That's fine too. So their minimum is 0.3 for the whole millimeter. I don't know what the hell that is. Oh, 11.81. Okay, so yeah, I just set it to 12 mils. So 12 and 24 works fine. That's usually the smallest you can get with these cheaper fabs. Typically you can do smaller if you're using like an actual good fab, but it's also going to cost more. Okay, so yeah, here, the inner copper and drill. So this is on inner layers, so it doesn't really make a difference for me because I'm only doing a 2-layer board. But if you're doing a 4-layer board, you would have to do that. For grid copper, not doing that either. This is for 4-layer, not doing that. Hole to hole is 10 mil. So yeah, I already set that, that's good. So yeah, that's about it for that. Can you do other fonts for the silk layer? Yes, you can do any true type font, which is really cool. But the kind of shitty thing is, like artwork and logos and stuff, which is usually really easy with KiCad, is not very easy in Altium. Which kind of sucks, but at the same time, I don't really do artwork, so it doesn't make a difference for me. So anyway, these are all of our switches that we imported. And this is ugly as shit. So we're making it not ugly as shit. How do you do that? Find your MX1. So this is my escape key. We're going to set the origin to the center of this. I think it's storming again. Is it storming again? Yep. Severe thunderstorm watch. Sick. So if my power goes out, rip. Anyway. So this is my escape key. This guy right here. And so I have that set. I'm gonna set my grid. So I set my snap grid. I'm using hotkeys because it's just easy because I know them. So I'm gonna set my grid to 43.4375, which I think is like 750 divided by 32 or by 16. So 750 mils is 0.75 inches, 3/4 of an inch, which is the imperial spacing. So it's the same as saying 19.05 millimeters. So yeah, this will make it really easy to place all these. So let's grab our first row, which is going to be like most of these. So I have my 34. That's going to be my, this is my page up key, if I remember correctly. Yeah. So we'll do that one last. So anyway, this shit's super easy just to click and drag at this point. I just want to turn off my hot swapping, my snapping. So this will, it's kind of fine right now because I do have such a fine grid, but it's useful for spacing. So you can see how quickly and easily these just kind of snap in. And I have thought about doing like a script or something, but it doesn't make a difference to me. This is easy enough just to fucking do this, basically. And they're all going to show up as like bright green because they're technically overlapping. And Altium doesn't like when it's saying the footprints are overlapping, but it doesn't make a difference to me. And I'll just clear it out anyway. So yeah. So MX14 was my short slip backspace, yeah. And see, this one's actually going to overlap. So you have your 2U in the center here, your split 1U on the right side, and then your split 1U is a fully separate key on the left side. So here's my page down. So what I like to do here is I have these little green tick marks along here, and this is splitting the switch. So like this is half of a U, this is a 1/4 U. So to make sure that this is spaced a 1/4 U apart exactly, I just drag this over, line it up with that little tick mark, and we're good to go. And I'll do the same thing here just to double check. Easy game. 17, 18, 19. So yeah, there's the top row. And we just do that for the rest. So yeah, it's really straightforward. Let me grab, nope, wrong thing. 34 is page up, 53 is page down. Let me find MX53. What's up, Elgo? So yeah, that's good to go. I think these are my numpads, my numpad keys. 35, 36. I don't have my comments on for some reason. I'm not even sure what layer they're on. Yeah, Altium is definitely expensive. I have the luxury of, because since I use this at like my real job, and I've also used it since college, I have 2 license options available, which is really sweet and definitely useful for me. But yeah, the problem with hobbyists getting into Altium is, yeah, it's expensive. I'm not really aware of any kind of like hobbyist or educational licenses anyway, but they might exist. Let's see, I fucked this up. 21. But they might exist. I would try to look into it if you can, or if you have like a university or work affiliation with anything like this, check them out. Because it's, and a lot of this stuff does apply to KiCad and other softwares too. The methodology might be different. It's like a couple $1,000 bucks. But yeah, like the methodology might be different for a lot of this stuff, but like the overall idea is typically the same, which is kind of nice. Because yeah, like I said, a lot of this can be applied over. So where's this one go? This is gonna go like there, I think. Yep. Damn, this is fucking hardcore music right now. This is some random playlist I found on Spotify for like copyright free shit, so. Oh yeah, dude, I do agree. In undergrad, I didn't learn any kind of PCB design stuff at all. It's pretty much all just like self-taught. But like obviously, you know, your principles of stuff in. So this is, I think, the half, and that's not on all the way. So that's not good. I don't like that. Do I have that on a different? Nope, wrong one. Yeah, like I didn't learn any of this stuff. Where's the pain? Oh no, so every row is not split by a quarter U. That's only when you have like a bezel or a spacing. So, did I close it earlier? No, I didn't. I was just using this. So the only time you have like an actual spacing is when your keys aren't touching one another. So like these keys are all directly next to each other, but these insert and delete or whatever you want to call them are separated. So there's going to be a bezel here on the case itself. So you have to make sure you space them properly on the PCB side, which is what I did here. What was I doing? Oh yeah, combo, num. Oh, I like don't have that on. Well, I have this one on. That's good enough. I guess this is one I didn't really update. But yeah, not really having too much of this exposure undergrad kind of sucked. Where's the ISO? ISO's right here, dude. It's so ugly. It's all you. It's there. Don't worry. This is my split left shift, and then this is the rest of that. My fourth row. So when you're placing these, it's easy to think like, okay, my next key goes here, but this is your short 1U for the ISO, so you got to make sure you overlap the right stuff. Oh no, the song said goddamn, that's so bad. Oh yeah, dude, Mr. Keebs is awesome. Like I said, I've actually thought about doing a script to do this for me in Altium, but I don't really mind doing it manually. It's easy, so I'm fine with it. 75, and this would be my 2U enter for the numpad, my 1U. Where are my arrows? Did I forget my arrow keys? Ha! I forgot to put my arrow keys in. Alright. It's easy enough. MX, we'll call this one up. Left. Down. DN. We'll call this one right. So we'll just annotate those in, and they'll just have a different name. Or they won't be in order, we'll call it. But that's not really a big deal, because I know where they're supposed to be. Place, import changes. What am I making again? So I'm making a keyboard from designing everything. Disable all of same kind, disable everything. I only want these MXs. So I'm working on the PCB. Getting the PCB to a point where we can import it into CAD, and up is 89, 99 to 192. So you can eyeball, make sure it's fucking lined up. It's actually not lined up there. There we go. So yeah, I'm designing a keyboard from the ground up. We're just gonna get the PCB to a point where I can import it into CAD for now, and then we'll do the rest of the PCB work after, because I don't really feel like doing it right now. So yeah, let's go there, let's go there. So let's see here, 76 is my control. There's our 1U. And my 7U space will slide in here. Thank you, Tizark. So, Salt Rock, I don't know what it might be like in KiCad, but typically if you just place components, you can, like in Altium at least, you can go back in and add the nets after. Like, I don't have any nets right now, but I can go in and backfill those pretty straightforwardly. In a very straightforward manner. That might be a better way to say that. Thank you, Natoria, for subscribing. What the fuck? I got people subscribing? Bro, this is wild. So yeah, right here I'm overlapping my 1.25 U's. The other thing here I gotta do is make sure I have my left side lined up correctly. So there's all the switches lined up. So at this point I'll just move them a little bit. Oh no, I control cut them, that's fine. Yeah, I like placing this stuff physically and then backfilling with nets, especially in something like this, because the net list just gets annoying and it gets all over the place. So yeah, I could do that. I think USB. Oh, actually I'm gonna change my center again. So my USB port, I'm gonna center it here. I'm gonna make sure I leave enough room. That might be kind of far out. Because typically I'll just do a, I'll typically put it on like a knot right here. I think I can make that work though. We'll see. Let's see how I make that work. Now we see the outline. So I turn off these couple layers. Actually, I'll leave that on. So I do my outline in my first mechanical layer because that's the one I'll export. And we'll keep everything. We're gonna keep it pretty narrow. And then kind of annoying thing, I guess you could call it, is we're gonna have a little like part jut out. We'll handle this in a little bit. We'll handle the stabs in just a little bit. But the nice thing here is you can make this like nice and fancy. That's kind of ugly. That's kind of sick. All right, cool. So instead of just keep going and like freeballing this, I want to actually copy this and paste it here. So it's uniform. I'll turn that thing back on. No. All right, cool. Oh, this is a fucking bop. Compatible with Blackbird. I don't think it's gonna actually work like in the current Blackbird. It's just the same base layout. And this will keep pretty small. I will do the same thing here because I like keeping these consistent. We'll lock that so I can't move it. And I love the copy and pasting with like a reference point. So you can copy something and just like with a specific point in mind and then paste it on that same point. Super easy. Oh no, I think it overlapped. Yep. All right, cool. So now we select DSD. Oh, that hit tab. So that selects everything. DSD. Why isn't it working? Oh. I gotta delete these, I guess. Alright, so there's the board. Pretty straightforward. But this is kind of too far out for my liking. We're gonna, I like to take most of my stuff, lock it so I don't actually drag shit around. Yeah, dude, rectangular PCBs are just boring, dude. Imagine a rectangular PCB. Could be me. Could be me. Might be me one day. But it's not me now. Too good for that. Yeah, we'll do that. That looks a little better, I think. Here's gonna do this line. That's cute. That's so cute. Actually, no, I don't like this again. I don't like this again. I'm gonna have the least amount of overhang on this part as I can. Redo it again. Redo. That's better. No, there we go. This is the kind of stuff that I like struggle with making fully right. Hey Neeson, thank you for that follow. So that'll look kind of cute. Yeah, that's nice. That's better. Dude, circular sounds wild. That'd be so fun to maybe try one day. So I'm gonna delete. Actually, I don't want to delete that yet. So I'm gonna turn off a couple of these layers because they're getting in my way. So yeah, the nice thing about making sure your stuff are in different layers is you can turn different layers on and off. You can do it in KiCad too, just to make stuff cleaner. So like not having all these little dashes and not having all my like the footprint sizing makes it so much easier. So anyway, I want to do something fun here. This would just be for the stab area. Yeah, it's long. That's unlocked. Delete. Can I delete it? Okay. I will copy this. Using that whole poop. Fitboard. Gasket mount this PCB. I don't really see the point in doing that, to be honest, because I don't really like gasket mount stuff that much myself. So I think I'm just gonna do a traditional top mount with burger option. See, I like this look. I don't know if that's gonna be nice enough for me. Nope, I don't like this. We'll do it that way. Whoa. Oh, these are a little offset. Okay, that's no big deal. All right, cool. That's nicer. That's better. Songo Can, thank you for following. How do I decide how much border? Typically there's like a minimum that you need to follow with manufacturers. Actually, this is ugly again. Fuck. So it's typically gonna be like, I want to say like, I think you're gonna need at least like 10 or 12 mils from the edge of your board to your first component or your first ground pour area. Typically to the component. This has a little more than that. Like this is probably pretty damn close to the limit. Like this whole radius here. So that's, could be like, I could make these as small as I want. Like I could put this right up alongside this. I don't want to do that though, just to give people a little more area. And I think having less like free room in the case itself is better for sound. So when I go to do the inside of the case, I want that to follow like this outline as much as I can, and you can't do that as well if you have a very small PCB. Like this gap here, which is like I think 23 mil, so like not much at all. That's probably about as small as I would go. Sorry, how do we do this again? All right, no, cancel. We're gonna make this even nicer. So I'm gonna start. I'm gonna start there. Yeah, I'll start there. Fuck it. All right, that might be too thin. This is, man. It's all this kind of shit, man. You never know. All right, that could work nicely for me. Yeah, that's good. That's happy. I'm happy with that. Yeah, this is Altium, not KiCad. I should maybe do some KiCad stuff just to stay brushed up on it. But then again, this is better, so I'm not going to do that to myself. Well, Babbling Brook on this song. That's kind of cute. All right, sweet. So that should be good to go. 7749. Okay, so I'm missing something, or there's an overlap somewhere. 7749 -3. 7749. Okay, so right here. Oh yeah, here's like you can see this is overlapping. Fixed. So there's a new outline, and there's the board itself. Probably. I don't really follow EEV blog or watch their stuff too much. However, probably should. All right, so here's the bare minimum. Like, actually, this is a lot less than the bare minimum for what you need for a PCB. You know what? This might be fun to do a fucking. Oh yeah, no problem, Sarvic. Appreciate it. Yeah, those are even old. I have newer ones that I haven't released because I don't have any of the legends done. But yeah. So I'm not fully concerned. I'm not fully happy with how far this PCB port is sticking out. I might do a daughter board on this. We'll figure that out in a couple minutes. All right. So anyway, at this point, we could go and take this thing into CAD. Last thing I need to make sure I do is get the proper thickness. So right now, oh, it already is. Cool. 1.59, 1.6 millimeter. That's close enough. DCS. I've actually kind of started working on DCS, which is funny. So I will get to that. I'll finish those someday, at some point. I don't know. Eventually. So at this point, we could take this, export the step file. We'll just save it as the default name. Export all bodies. Component suffix none. And this is nowhere near done PCB wise. I have no diodes, no resistors, no anything electronics wise except for the USB port, which we're probably going to change anyway. So now, let's open up SolidWorks and do some SolidWorks stuff. Where are we at here? Right, well, like an hour and 15 minutes. Perfect. So I'll start probably with the plate, at least for sure, and then probably start doing some of the top case. My main goal here is to see how exactly I want to handle doing this USB port, because like I said, it's ugly. I don't really like how far it's sticking out at this point. How much does a PCB like this cost? Like during a group buy, typically these things could cost like, you know, $45-50 depending on components and how many. If I were to, you know, order 5 of these blank and order components for them, or have them assembled by like JLC PCB most of the way. Typically, that would probably be around $25 a piece, maybe more. Actually, probably more like 35. But keep in mind, like the group buy price, like for a keyboard or a PCB I design, is different, cost wise, because I'm gonna charge more to earn more money, basically. So yeah, I mean they're not super expensive. So here's the 3D model of my PCB. We'll just save it as a SolidWorks CAD. Cool. So there's my PCB model. What we'll do now is make an assembly from this. We will import this. Make sure the orientation is correct. So yeah, there's my I want to mate this to the top. Oh, that's a fixed component. Never mind. So we're basically going to design everything relative. What the fuck did I do here? We're going to save this as IBIS case. So we design everything relative to the PCB. At least I do. Is the easiest way for me to verify that the PCB will in fact fit in the case, because there's numerous instances where the PCB doesn't fit perfectly. Why is this still yellow? Alright, fixed. There are instances where this stuff is not done right. Unfix and align planes? How do I align the planes? Oh. See, I'm actually not that great with SolidWorks. Like, I know how to use it, but as far as like tips and tricks go, I'm not that great. How to align a plane? No results found. It doesn't matter. I'll just mate it. That's how I know to do things. Top. Nope. That works for me. And now I'll fix this. That works for me. Yeah, large PCBs, because they do charge based on like size, an area, so they can definitely get more. That's fine though. All right, so there's that. So we have our top plane here, which is relative to the top of the PCB. So the first big distance to make sure you're using the right way is the distance of the top of the PCB to the top of the plate, which is 5 millimeters. So I'm gonna make a new plane here that's offset from the original one, 5 millimeters. And we'll name this plate top. Oh, I see. Okay, cool. Yeah, so I don't really do math stuff too much. Besides like, hey, this is how much this thing could weigh type deal. Because I don't really do too much simulation or other work like that. But yeah, I'll look into that because that would be good to know. So anyway, plate top. We're gonna make a new part on this face, and we're gonna name this part IBIS plate. And so a lot of people actually do like a full-on sketch. Like they'll sketch out their switch footprints. But my favorite thing about SolidWorks is I can actually go in here and I have documents saved, or they're called blocks. So I have a whole shit ton of them saved already. I usually use these MX no cutout ones. Ah, no, I keep remembering I fucked that one up. No one. So you can just take these blocks and just place them. And they're all relative. So if I change this block, I have to go back and like edit every block, which is a pain. So I'm not gonna do that. Actually, I am gonna do that right now. Edit block, because I wanted to make a construction line, a circle in the center of this for construction. And you can see it changed all of them, which is really cool. I'll just resave this existing block. Keycaps, keyboards, SW blocks. Where the hell is that saved? Cool. So these blocks, this inner cutout, this is 14 by 14 millimeters. 14 total, 13.6. It says this length is because these radiuses are a little smaller. And then the overall size is 19.05 millimeters or 0.750 inches, which is the proper spacing. So placing these out is the perfect 1U spacing. So what I want to do next is I want to take this. Oh yeah, see, this is like a fucking ugly ass chain. So these are all coincident only on those corners. So actually, we'll just restart that. So I can have a sketch, blah, 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 point. This is the center of my top switch. So that's gonna be fixed. So I'll just drag this here. That's my top switch, my first switch. And now I can just insert the rest of the 1Us like super fucking fast. I'm not really worried about the turning of them and stuff. And then I'll also do, see, I switched to this smaller buttons, and I like don't know where anything is. Copy. I'm gonna copy relative to that and then just paste. Super quick and easy and fast. I'll do the same thing here with these holes. Pretty much only on the ones that I'm gonna need to center. I'll just copy this. No. Yeah. I've done the sketch patterns a lot too. I usually just find this easier since it's like one click and you're good to go. Whereas with a sketch pattern, you have to worry about your axes and all that kind of stuff. And this is easy enough just to do this. Copy. 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 And you might be asking, you might be wondering about like, what about the 2U cutouts, that kind of stuff? We'll do those after. I'll do those on a separate layer. For right now, I'm just doing the 1Us. Well, I guess just a base easy layout. There we go. So do 1.5, and I also put those little divisions on these, not as many, so it's not like as perfect or great, but it does a good job. What's up, Jeff? So typically, yeah, I'll just place these based on the top corner. It's just an easy reference point. Actually, I'm gonna copy a bunch of these again. Yep, and these all just line up really fucking nicely based on my stagger. And then you can delete these extra ones you don't need. Cool. Nice. Now I just gotta worry about a couple other, like, more specific ones. Step caps. 2.25U one way. So I named these kind of weird, but it's just like easy for me to remember. So there's like my enter, and actually this isn't one. Yeah, I don't know. I switched stuff over. It's like a Vici Brother fake version. Yes, basically. Yeah, the alignment markers help a lot, especially when you're just trying to do this. Like, it makes your workflow go really fast. And I think at one point I had a block that was like most of these alphas, but I fucked it up. So I don't really use it anymore, obviously. So that's for north. I just rotate it 180 for south. And I do, what, 2 more 115s, blah, 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 da, da, da. All right, cool. So this will essentially be like a fixed layout plate right here. Actually, I don't want to do these. I want to do the full on 2U. All right, cool. So those are my switch cutouts. Ready. Now I'll do another sketch on the same plane. And this will be the outline of the plate. So there's no alignments or anything right now. So the first goal of this is just going to be making sure things line up how I want them to. So the outline of the caps I don't really put in typically. We'll just do one here like for simulation. Make these equal. 18.2 millimeters. So I want to make sure that the plate extends further out from like the center of the switch than the bezel will of the top, and 2, that doesn't extend too far. So typically I will do my bezels at like 0.9 millimeter. So this is just like a line for the hell of it. 0.9. So I want to make sure this extends like 0.2 beyond that. No, not fucking length. 0.2 millimeters. It's pretty small. That should be like 10.2. Yeah, okay. Get rid of that stuff. 10.2 millimeters. And we're gonna make this dimension equal plate spacing. Yes, create a global variable. And then instead of putting in 10.2, plate spacing. We get out of this corner, select this 1U, and do the exact same thing. But we don't want to do the vertical. We want to do that on our furthest down one. So that'd be this one. 10.2. All right, cool. So that would be the start of our plate. I don't want to keep all this like that. So I actually will, you know what, we're gonna do it this way. I'm gonna make a corner kind of cutout thing here, which will be the same. .2. Same thing here. Keep typing it in. And I can trim that and that out. And so you might hear my girlfriend sneezing upstairs. RIP. And the plate doesn't matter. So like, since this is above, like since this is kind of intersecting that, it doesn't make a difference because the plate is higher. Don't forget. All right, since these two are floating, if they're blue in SolidWorks, they're floating points. Like I can change this dimension I want all day. I don't want to do that. And so we're gonna make this the same thing here. Dimension, not M for measure, D for dimension. But instead of, pooper. So there's that. And then instead of doing a true dimension here, we're just gonna select these two and make them collinear. So that forces this to be stuck completely in line with this one, which is nice. Now we do is we So your sketch, extrude it. Make sure we're extruding down because this is the top plate, the top face of the plate. 1.5 millimeters. So there's our base plate. If I turn the sketch off, you can see it's just one solid piece. And then we do here is we select our other sketch with our blocks, extruded cut through all, and there's your plate. Turn that back off. So that's the start of the plate. What keyboard am I using right now? This is my KFE with Hasbro here. I'll just unplug it. It's a wide-ass angled lens on that fucking webcam. So, like I said, my big concern... Thank you, Jack Static, for resubbing. You gave me money. You gave me money once. I don't know why you want to do it again. But thank you. So I'm going to show the sketch again. And I want to make... Actually, no, I don't need to show the sketch. So I'm going to make a new sketch here. So this would be another one of those instances of like a reference point for a switch. So this would be like, nope, not perpendicular, equal. So this would be another reference point for the switch itself. So I want to make sure that this USB port isn't going to stick so far out that it's going to be super ugly. So yeah, so that's 8.2. We're just going to draw a couple of lines here. So there's line 1, and there's line 2. So these two lines are reference points, or not reference points, I guess just visual interpretations of the case. So think of your top case, like this is your bezel. So I'll make sure my inner bezel is what? 0.9, like I said. So this is where the inner part of the case is going to sit. And then this is the outer part of the case. 5.8, that's pretty good. I usually like to make my bezels kind of thin, like less than 7 if I can. 6.5, so if I do 6.5, like that would be flush, which could kind of look sick, but I don't know if I want to do that. I don't know if I want to make it flush. I don't think I want to do that. So let's just make it a little memey. Because I just don't like the idea of a flush USB port. I'll make that 6.9. 69. That's a good number, right? 6.9. Cool. So do that. And that might look nice. Alright, sweet. We'll mess with that. We'll start with that. I'll make a new part again. This is going to be my top case. I made it on the face, this top surface here, the plate. We're going to start not with a rectangle, but with some individual lines. So what I want to do here is just do like a quick, dirty outline of all my parts that would be like technically cut out of the plate. So where my switches are like literally going to sit. And I'm just doing this, you know, kind of randomly. Nothing lines up yet. Nothing's going to be equal. Like, that's not even fucking horizontal. Holy fuck. Now it is. All right, sweet. So now we can start lining all these up. Collinear. I love the collinear ones. It's just easy and nice to do. Just kind of lock some shit into place. Collinear, collinear. I'm not gonna do this middle one collinear because the switches stick out further. Collinear. Nice. So when I drag this down, all three of those are gonna drag with it. So I actually want to make these collinear with that now. So that's gonna be my true inner surface. And now the kind of annoying part is I need to figure out the distances for the rest of these. So it's gonna be exactly 10 millimeters, which should be easy to do. I'm just gonna type in 10 on these. May as well. And actually what I can do with this is line this midpoint up with that center. So that way this side's perfectly aligned as well. Equals 10. Good enough. I'm just gonna put these on a bunch of switches to use as references. Put this on this one as well. This is probably a little messy. This isn't like the best way to do this, honestly, but it's quick and dirty and it works for me. So if you're doing this, you might want to take a little more time and like actually line the stuff up the right way. But yeah, this is my way of doing things, not the right way to do things. Okay, so another annoying part of this is like if you're not doing, because I'm referencing all these off of 1U switches right now. So like here where it's either a 1 or a 1.5, you want to make this bezel the same as like this. So what I usually do is I'll do that, dimension it, and this is called a driven dimension. So it's like you can't physically just change it because everything else around it is already fixed in place. So this driven dimension here, this 3.81, is based off of these other spacings and other dimensions and other, tells the word I'm looking for, relations between lines and points that are already in place. But they're super useful if you're trying to reference something. So I want this to be the exact same distance as that, so I just do that. So this is now this dimension. And that's verified. And then I just have this last one. So this would be my inner bezel of my top case. But now I want to do my outer bezel. So I will just draw a fucking rectangle again. What did I say, 6.9? But I want to do my outer corner, I guess, side bezels. Like, I like doing like 2 or 3. We'll try 2 out. 2's pretty narrow. No, let's do 3. I like the little chalk on them. And then I want to make this one. This is going to be a little different. Make that closer to like 6.4. What's this dimension here? 1.6. That's good enough. I'm gonna say there 3. Say 3 again. All right, cool. And we take that and we extrude it up. I like doing like 7.8 for my bezels. Anywhere between 7.5 and 8 millimeters is usually really good for GMK caps. Sometimes you need a higher bezel for like SA or DCS because on a GMK cap, I can literally fucking show you. Keyboards, keycaps, new Cherry MX, blanks, row 1 solid part. So, why the hell do I have like a fucking lighting environment in here? Anyway, so the stem is not perfectly aligned with the bottom. It's a inset roughly 1 millimeter. It's pretty much just 1 millimeter. So your keycaps will sit a little lower within the keyboard system itself. versus like SA caps, and I think DCS are the same way, where they are actually flush with the bottom. So you need to account for that with a higher bezel more often than not, or just don't use them. So yeah, there's the top. And I actually don't really like how that looks. Let's rename this Ibis top. So we're gonna edit that. We're gonna make that 7.2. Honestly, I just kind of eyeball it and just like guess. That's a little better. Cool. All right, nice. So the only other thing I really want to do right now is add some fillets to this top portion. So I like to do 1.55. You could typically do 1.5. That's what like my manufacturer recommends. The problem with doing straight 1.5 is they'll use a 3 millimeter diameter or 1.5 millimeter radius end mill to do them, and you don't want a tool to have the exact same radius as the part you're milling, or as the curve you're milling, because it's like a in and down versus like it actually following the curve. So I add like 5, what was that, 100ths of a millimeter on, which makes it nicer. And you can like select all of your inner corners and shit, but I have outer corners that I don't want to make that radius, so I don't want to select those, but I will do that here. So fun. Anyway, I'm just going through fucking getting all these corners selected. We'll probably miss one or two, but that's okay. I can always edit it. All right, there's my outers, and then I'll do like, I like to do like a 0.3 on my outer corners, just to be enough to like not be a hard edge corner, but it's just enough to like round it off and make it look kind of nice. Another thing to keep in mind when you do that is your inner radius is going to be your limiter for how deep of a chamfer you can do on your top surface. So here I can do a maximum of 0.3 millimeter, which is what I normally do. But if I do a 0.5, this is so small that it like doesn't really work physically. You can make it work, but it's not going to look good. So yeah, I do like a 0.3, we'll call it. And it's still like, it's enough to keep it nice and like square looking, but knock the edges off and give it a good little adjustment there. Save all that. And I haven't done any kind of plate cutouts. We'll do that down the line. I also have to add in the rest of the like the other switches and like the other cutouts and stuff on the plate. Another thing to note here is we'll do a little more of this top actually. So I like to bring my top down to meet the midpoint of my USB port. That way when the top and the bottom close together on it, it's like a really nice looking good sandwich. So edit this component one more time. I'm just gonna put this face. I'll do a center line. That's just a reference. Like, just make sure it's somewhere in the center. Like, this is obviously not the same points on either side, but doesn't make a difference. Thank you for following, Kepston. Much obliged. And so here, we're not going to do a full-on, like, just extrude. We could, but we don't want to do that. So I'm going to do convert the outer corners, the outer edges of this. This isn't working. Oh, I got to sketch first. Convert outer corners. All right, they're done. But now I want to do like, because this is going to come down further off the plate. Like this was going to surround the plate itself. So I got to make sure that I am outside of that. We'll call that 2.2. I'm eyeballing these. As long as it just is pretty tight, typically you're usually okay. That's how most things are. If it's tight, I'm usually all right. Unless it's too tight. What did I say on the other side? 2.2 or something? Yep. And I'll do the same thing down here. We'll do this. Vertical, boom, lock that in. I'll make this 63.7. We're gonna have to round this once we get to that point. I'm gonna stop doing it right now because I don't care enough. All right, so we're gonna extrude this feature. You can see that there. We're gonna extrude it to this line up to vertex. Well, to that point, I guess. Extrude, blah, blah, blah. So now perfectly intersects USB port, which is pretty sick. Now last step, edit component sketch. I'm gonna take this, offset entities. I offset them like 0.3. Nah, 0.2. We'll call it 0.2. Construction geometry, blah, blah. Bam, so that's sick. Features, cut through, that's good enough. All the way through, and there's my USB cutout. Oh, the start of it. Thank you, Scottwater, for that follow. So yeah, that is, so now what I'm gonna do here now is like inset this a little bit so the USB port's perfectly flush. That's gonna look sick. I should probably do that right now, actually. See, this is where I should have done that the right way. I forget how big I make these, like 16 by, I don't know, 6.5? Oh, Coinstorm with a host. Thank you, thank you, thank you. Make this 15. I don't know. I can change this down the line. I will at some point. And thank you for the follow, Coinstorm. I'm going to fillet this like 1 millimeter on the corner. I'm going to do all 4 just because even though these top ones don't matter. All right, cool. And, oh no, I didn't even do that on the fucking part. That's okay. That's actually a good thing. Because now I can edit this, do a sketch on this surface. And what I'll do here is I'll take that sketch I just made, convert it, and now this is referencing it. So I can do the same thing on the bottom half. Super easy. Extrude cut up to a surface, and I want that surface to be, why can't I select that? This. No, what the fuck? That's not what I want to do, bud. I want this to select, hopefully, this surface. Does not like that? I guess it doesn't like that. Blind. 0.4. Alright, we're just gonna eyeball it. Oh, wait, here, I'll just do up to vertex. There we go. All right. So now, at the end of the day, that'll be perfectly flush. 3-foot pipe. That's just the RGB. So yeah, there's my USB cutout. I can turn that sketch off. So yeah, that's super easy, super nice, super good to go. There's actually, I'll have to make a cutout on the plate here. Turn this off. So, nope, wrong one. the USB port will like kind of cut into the plate here. So we're just gonna add this sketch center line onto this surface. We'll reference that. Blah blah blah. Make this come out just a little bit further. No, not a center point. Corner rectangle. Vertical. Coincident. How wide is this? 12 is good. And how deep do we want to go? 2? Maybe 2? Money team. Cool. And we'll do these fillets again. 0.5. I think that's what I use on these inner corners. And we'll do the same on the outers. We'll do 1 point. We'll just do 1 straight up, just 1. Cool. All right, nice. So as far as the PCB goes, we should be perfectly good now. So yeah, at this point, I'm gonna stop this stream. It's gone on for almost 2 hours. I don't want to make these too long and boring. Hopefully this upcoming week I'll be able to do more work on this. So that would probably either be the PCB or working on more of the case. Probably whatever I feel like doing. So yeah, that's kind of fun and good. I'm happy with the progress made. It took about 2 hours, like I said. So not too bad given everything. Looking good. Thank you. Oh, that's great. What's up? Is this a proto? Yeah, this will be. It's just a Duck Blackbird logo. Thank you, Mountain Blocks, for cheer again. Duck Blackbird layout, but my spin on it, we'll call it. I'm thinking of maybe doing some kind of indicators, something like fun here with like a little RGB daughter board, perhaps. I don't know. We'll figure it out. So yeah, we'll keep it going, make it work, make it look good, hopefully. Do some fun proto shit. So yeah, all right guys, thanks for everything. I'll see you sometime soon.